So, dear student, welcome back. So, I'm explaining here little. First of all, I'm going to give you a little brief about the dihybrid cross. We know that the dihybrid cross it is the cross done to study the inheritance of two characters at a time, or taking four traits at a time for our studies. That is called a dihybrid cross. So, I was thinking in depth about this concept. So then I was like worrying that can I give some alternative definition for this? So then I came to the point that yes, I can give the another alternative definition for dihybrid cross. So then from my perspective, I was thinking that all of you know that hybrid means it has the characters of the both parents in equal amount. So that can be called as hybrid. But another here, hybrid means I am taking it as an heterozygous pair. So if you see in monohybrid cross, there is a formation of one heterozygous pair. Say for example, if you consider tall dominant pure parent having genotype capital T and the dwarf recessive parent having genotype small t. They are the pure parents. So we always select pure parents. Now my question to you, how we're going to get the pure parents? What kind of things we're going to do, right? So we need how to do continuous selfing. So after doing continuous selfing, then we gradually attain the pure plants. So the pure plants are also called as true breeding, you know, pure part, pure plants, homozygous plants. So that we have to select. So in mono hybrid cross, we get capital T small t as a genotype in F1 generation. If you see this capital T small t, what does it mean? So hybrid is there, but hybrid is having only one pair. Therefore, the word comes as monohybrid. Let's take about the case of dihybrid. In dihybrid, you have studied round and wrinkle, yellow and green, seed shape and seed color. If you are taking these two characters for your dihybrid class to study, so in F1 generation, you will be getting two heterozygous pair, two two diheterozygous pair hybrid. How is it? This definition seems little okay. Yeah. So if you feel it like, this also can be the explanation. So please remember it because if you remember this, we're going to solve many questions over it. Just observe about this dihybrid cross. It is a cross done to study inheritance of two characters or four contrasting at a time. So he selected two characters for the experiment. Here we are taking two characters, that is seed shape and seed color. The question comes here, why he needed that, why he wanted to study the hybrid cross, and the simple reason for this, he just wanted to see the inheritance of one character is actually depend upon the inheritance of other character or not, or the inheritance of one character affects the inheritance of other character or not. So that was the simple reason behind the study. So we selected the pure parents, we formed the gametes, and then after crossing, then we get this F1 generation, capital R small r, capital Y small y, having phenotype round yellow. In F2 generation, we know that we do selfing. After doing selfing, we got this checkerboard Punnett square of the 16 zygotic combination. So here, the important thing we have to discuss is, if you see what all things we got here. If you talk about the phenotypic ratio, then we have got round yellow, which was resembling to the original parents. If you have seen, capital R, capital R, capital Y, capital I, that parent also having the phenotype as round yellow. And then wrinkle green, that is also phenotype of recessive parent. So these are the phenotypes which we have got, which resembles completely with the parent. But then again, you can see here, we have got new phenotypes, round green and wrinkled yellow. that was never before in ancestral line, है ना, पेरेंट में पहले कभी था ही नहीं। तभी इनका अगर आप फिनोटिपिक रेशियो निकालते हो तो वो आता है 9:3:3:1। तो फिर आगे जाके अगर आप देखते हो जीनोटिपिक रेशियो, तो फिर आपको पता था कि मैंने आपको ट्रिक बोला था कि कैपिटल आर ले लो, कैपिटल आर स्मॉल आर लिखो, कैपिटल आर लिखो, कैपिटल आर स्मॉल आर लिखो, कैपिटल आर लिखो, कैपिटल आर स्मॉल आर लिखो, फिर स्मॉल आर लिखो। फिर दो हाथ को आप लिखना है कैपिटल वाई कैपिटल वाई, कैपिटल वाई कैपिटल वाई, फिर कैपिटल वाई स्मॉल वाई, कैपिटल वाई स्मॉल वाई, फिर स्मॉल वाई स्मॉल वाई, स्मॉल वाई स्मॉल वाई, एंड देन कैपिटल वाई वन वन पेयर, कैपिटल वाई स्मॉल वाई, स्मॉल वाई स्मॉल वाई, and then ratio you have to understand at 1:2, 2:2, 2:4, 1:2, 1:2, 1. And then this is also very important to note it down that if both pairs are homozygous in 16 combination of checkerboard, it will only going to repeat one time. If one pair is homozygous, other is heterozygous, it will going to repeat two times. If both the pairs are heterozygous, it repeats four times, right? So then we have came to the conclusion of phenotypic ratio 9:3:3:1, genotypic 1:2:4, 1:2:1:1. Type of phenotype always use this formula 2:n. Type of genotype always use this formula 3:n. Zygotic combination 4:n, where n denotes the what? N denotes simply the number of heterozygous pair in F1 generation. Now, after getting the results of the dihybrid cross, Mendel proposed this law. That law is called as law of independent assortment. This law is very, very simple. जब आप दो या दो से ज्यादा कैरेक्टर की इनहेरिटेंस की स्टडी कर रहे हो, तो आपको ये सहज से ही पता चल जाएगा कि एक कैरेक्टर का इनहेरिटेंस दूसरे कैरेक्टर के इनहेरिटेंस के ऊपर डिपेंड नहीं करता है। वो ऐसे ही इनहेरिट होते हैं जैसे कि हमने मोनोहाइब्रिड क्रॉस में देखा था। तो फिर मैंने आपको बोला था कि ये आपको ध्यान में रखना, कभी भी एक चीज याद रखना, डायहाइब्रिड मतलब क्या है कि दो मोनोहाइब्रिड का क्रॉस है, ऐसा समझो। तो राउंड रिंकल 3:1 रेशियो आना ही है, और रिंकल फिर और येलो और ग्रीन इसका भी रेशियो 3:1 आना ही है। तो यहाँ पे आप समझ लो व्हाट इज इंडिपेंडेंट असॉर्टमेंट। आप देख सकते हो कि कैपिटल आर के साथ स्मॉल वाई भी आ सकता है या फिर कैपिटल वाई भी आ सकता है ड्यूरिंग गैमेट फॉर्मेशन, दैट इज कॉल्ड एज इंडिपेंडेंट असॉर्टमेंट। हाउ दिस कैन बी पॉसिबल? बिकॉज वी अंडरस्टैंड द जीन्स आर लोकेटेड ऑन द डिफरेंट डिफरेंट क्रोमोसोम्स। लेकिन अगर जीन्स अगर एक ही क्रोमोसोम पे बैठे हैं, तो क्या आप बोल सकते हो कि आर के साथ स्मॉल वाई भी आ सकता है या फिर स्मॉल आर के साथ कैपिटल वाई भी आ सकता है? ऐसा कभी भी नहीं होगा। क्यों? क्योंकि जीन एक ही क्रोमोसोम पे बैठी हुई है, तो फिर दोनों क्रोमोसोम सेपरेट हुए ड्यूरिंग गैमेट फॉर्मेशन, तो फिर वो अलग अलग रास्ते जाएगी। ठीक है ना? तो ये लिंकेज का कंसेप्ट है। तो आप यहाँ पे बोल सकते हो कि द एक्सेप्शन फॉर द law of independent assortment is a linkage. You understand? So this is the things which we have studied. So now we are moving ahead to solve the problems, because everyone's life is filled with problems. If they're not going to solve the problems, how they're going to succeed? Yes.